Welcome to the TIEEP podcast, brought to you by CECO and Energy. I'm your host, Gary Gildert, along with interns Carla Romero, Hisham Habli, and Christian Garcia. We bring you the latest in industrial energy efficiency in 15 minutes or so. We have upcoming events, we will recap some past events, and then we have an article that we will be discussing. So upcoming events include Coogs for Energy Hackathon. This will be April the 10th to 11th at the main campus. For more information on the hackathon, please see our newsletter. The 2026 AIChE Spring Meeting and 22nd Global Congress on Process Safety takes place here in Houston, April the 12th through 16th at the Hilton of Americas and George R. Brown Convention Center. There'll be many sessions. This is actually one of the biggest industrial chemical engineering conventions, and this will include multiple sessions on energy efficiency, including the energy efficiency in gas industry, which I will be chairing. Again, please see our newsletter for more details or go directly to the AIChE site. The Industrial Energy Technology Conference is back for 2026. It will be May 19th to 21st at the Houston Marriott South. There will be multiple energy efficiency and plant optimization technical topic areas. Registration is now open, and as a special invitation to our podcast listeners, if you have an abstract you want to submit, got to warn you, the deadline is the end of March. But if you email me, let me know the title and the name of the speaker, I can probably get you in somehow. I'll hold you a spot. So please get in touch with us for the 2026 Industrial Energy Technology Conference. Please check out the SPEAR website for more information on their seminars and webinars and other information for light industrial and commercial operations. So for a recap of past events, Carla, tell me what you've seen.
All right, let's start off with the Pinch Workshop. This was a 2-day event at the University of Houston Tech Bridge. CECO actually funded 100% scholarships for most participants. Alan Rossiter led the workshop. He is the president of Rossiter and Associates and our previous longtime leader in industrial energy efficiency education. He guided us through the principles and practical uses of pinch analysis. And if you don't know what pinch analysis is, it is a methodology widely used to improve energy efficiency in continuous plant operations.
So we were not able, or we're not allowed to record his workshop, unfortunately, for those who are most interested in it. However, there is a bit more information available from a previous podcast we did with Alan. So please check out that episode. Tell me a little bit about the Water Forum. What presentations did we have there?
We had 4 talks on water conservation. The first one was by Dr. Hanadi Rifai. She's from the University of Houston. The title of that presentation was Water, Water Everywhere for Lots of Drops to Drink, the Rhyme of the Future Engineer. And this was a great way to start us off at the forum. Dr. Rifai took us on a lecture journey through humanity's relationship with water. Then she broke down why the way we source, treat, and price the water should be rethought.
I know, that was an excellent talk. I really enjoyed that. So who else was there?
The next talk was by Luis Suarez. He is a principal process engineer at Fluor. His talk was AI-powered water treatment, engineering sustainable and circular solutions for the next generation. This talk was about cooling systems for data centers, how cooling technology has had to evolve to keep the pace, and why this current approach isn't sustainable forever. And he also talked about what a truly circular data center design could look like.
There was some great information in that talk, and I learned a lot about different cooling systems that are available. So what was next?
After that, it was a talk by Shil Basu, a senior principal at Stantec. The title of this talk was Beneficial Reuse of Produced Water from a Headache to a Lifeline for Data Center Development in West Texas. This talk was about how produced water from the Permian Basin can be used to cool data centers. From that talk, we found out that the Permian Basin produces around 900 million gallons of water a day, and 600 million of those go right back underground. This practice not only triggers earthquakes, but we're also running out of space of where to put that water. And do we know who's desperate for water?
Data centers.
Exactly. Data centers in West Texas.
I thought this was a great talk because it turned two problems into one large solution. A little bit on the expensive side, admittedly, but when you run out of room, you've run out of room. I thought it was a great talk. And finally, who did we have after dinner?
Dr. Carlos Gamara.
Our friend.
From HARC, exactly. His talk was Thirsty Data and the Lone Star State, the impact of data center growth on Texas water supply. In this talk, he talked about the structural blind spots in current planning. In this talk, he talked about the structural blind spots in current planning frameworks that could lead to local water shortages. This is all based on recent analysis done by HARC, examining hidden water and energy costs of Texas data center boom and implications for long-term resource planning.
It was really interesting just to see how the planning cycles are working. And as you said, the blind spots in that. There will be some local water shortages if they're not careful. When we talked to Margaret Cook, a co-author of this on our podcast earlier, we half jokingly saying, yeah, there'll be local water shortages. And when you can't flush your toilet in Odessa, that will be a critical shortage.
Yep. The next event was an energy transition webinar.
I actually co-hosted that webinar. It was with our friend Todd McAllister from Spear. He talked about the various initiatives that are through Texas and Oklahoma on improving energy efficiency for commercial buildings and light industrial facilities. It's a great talk. Oh, he was also a guest on our last podcast, if y'all remember. That was Todd. I suggest you go to the AIChE YouTube channel where his webinar is located for a lot more detail than we could possibly get into today. Speaking of which, all of these presentations will be available shortly on the AIChE YouTube channel. Next up, Hisham and I will be talking about an article he wrote on plastic recycling. Okay, so what did you learn about what happens to plastic waste in the United States?
So in the U.S., 86% of plastics are landfilled, 9% of them are incinerated, and only 5% are actually recycled. And that is out of a total of 50 million tons of plastic every year.
Oh, that's a very small proportion that's recycled. That's what we're going to talk about today. So tell me, what types of recycling are actually available?
So the most common of the recycling methods is mechanical. And then there's also a few others, such as thermal decomposition and chemical decomposition. And among those, thermal decomposition can be broken down into gasification, pyrolysis, hydrothermal processing. And then chemical decomposition can be broken down into chemolysis, solvolysis, and enzymolysis.
Wow. Well, before we get into all those, what kind of metrics are you going to use to evaluate these different methods?
So before I go into the metrics, in order to simplify our calculations and kind of get a better basis, over 50% of the plastics that are produced and wasted in the U.S. is low-density polyethylene and high-density polyethylene. For the capital cost, we will look at the cost of the process equipment for each of these processes.
Before we get into the recycling, do you want to comment on the landfill and incineration? Because this is like 95% of all our waste plastic.
So with landfilling, there's no useful energy gained from doing so. You are actually losing energy by having to process the plastic in landfill, which comes out to a negative 12.5% energy efficiency. But it is the cheapest recycling method at a capital cost of $7 per kilogram per day.
And incineration?
So with incineration, we do get a useful energy output, and that brings our energy efficiency to 24% because we get approximately 19.5 megajoules per kilogram from the process. And the capital cost ranges from $219 to $300 per kilogram per day based on a 1 million ton per year capacity spanning over 30 different U.S. incineration plants. And one important detail about this capital cost is that it does include a high capital cost with the emissions control equipment. So that is definitely crucial
So we get a net energy available from incineration, but I did my calculations right, about 30 times the initial cost.
Yep.
We'll talk about that again later.
Yeah.
Okay, so tell me about mechanical recycling, because that tends to be one of the more popular methods used here in the States.
So there is a benefit that mechanical recycling doesn't use that much energy to do. And of course, you are retaining the value of those plastics. You're not putting in the ground and you're not burning it. So you retain that full value. So it actually comes out to a high energy efficiency of about 88 to 94%. And then for the cost, it is roughly $210 per kilogram per day for mechanical recycling plants.
Okay, so that's a similar cost to incineration, but you retain a lot of the intrinsic value of the material.
Yep.
That sounds pretty good.
So with mechanical recycling, you avoid the potential for emissions, and you also avoid the need to have emissions control equipment.
But there are some more advanced recycling methods. Tell me a little bit about the thermal decomposition methods that are emerging.
Yeah, so with thermal decomposition, there's three categories. There's gasification, pyrolysis, and hydrothermal processing. So with gasification, there's really limited data on the process energy, but based on the product value, we can say that the energy efficiency would be less than 24%. And then for capital costs, because there's limited data on any current gasification plants, techno-economic analysis estimates a $488 per kilogram per day basis. And then with pyrolysis, there's no energy input data, but we do know based on the product value that the energy efficiency would be below 56%. And then with capital costs, there's no specific data for real life estimates, but a consulting company does estimate it to be between $300 to $900 per kilogram per day, of course, depending on capacity and the technology used. And then with hydrothermal processing, it is a very novel technology, but there are a couple hydro processing plants that are in the UK and Japan, but there was no data to even base a energy efficiency or capital cost on.
So these sound like some interesting processes, certainly much more expensive than incineration or a mechanical recycling in terms of initial capital cost. And producing just chemicals, just feedstocks, does not sound like certainly not as good as recovering the plastic itself. So the next trend, I think, is the chemical recycling. That sounds a little bit more promising. Tell me a little bit about the chemical decomposition methods.
So with chemolysis, it's similar to pyrolysis in that you're producing hydrocarbons, but you're going to be using an inorganic catalyst to chemically break down the plastics. But the main difference between chemolysis and pyrolysis is that chemolysis does happen in the presence of oxygen. In enzymolysis, you're using an organic catalyst to break down the plastics into its monomers, but it does take a long time to do so. With solvolysis, you're using a solvent to essentially dissolve these plastics down into polymers, and then you separate them, and then you retain the mechanical properties that were lost in mechanical recycling of the plastics.
Any word on the efficiency of these processes or the capital cost?
Yeah, so because these processes are still very new, there are no economic or energy analyses on them, but they do seem like very novel methods that maybe they're not a process of their own, but maybe they're integrated within, maybe mechanical recycling, or maybe they're integrated within the incineration processes, or maybe they're integrated within the thermal decomposition processes. So it's definitely a different method to bring new technology to the other common plastic recycling methods.
Okay, I'm going to show my bias here a little bit and say that the enzymolysis is very promising to just go to a monomer, but of course, solvolysis sounds even better to produce nice, clean plastic out of waste plastic. I think anyone could turn around and calculate these as energy efficiency are much, much higher than any other thermal method or incineration. So what is your conclusion from all this?
So with all these methods, we see clearly that the landfilling is the lowest and it is the most common, for that reason. And unfortunately, though, we are wasting that energy. So, and then, the second most common, still not very common, would be incineration, where some of that heating value is captured, but not all of it. The emissions control is still an issue that increases that cost, making it less economically efficient. And then with gasification, pyrolysis, hydrothermal processing, and chemolysis, you are producing a synthetic oil product and a fuel. And then with enzymolysis, you're producing a monomer. And all that being said, you are producing a higher value product than landfill or incineration. So they should be considered, but they are more difficult to evaluate due to limited information.
And there seems to be a lot more work needs to be done on those last two processes, but they do show a lot of promise. It's all a question, again, those capital costs down. And that may be a future podcast discussion. I think I know someone in that business. There's certainly research being done at the University of Houston on plastics recycling. So you'll hear more about that later. One comment I do want to make is the number of references you ended up with in this article was phenomenal. Why so many?
Among all of the articles that I've done, this one takes the cake at 24 references. And I really did try to reduce that because another article had 20 references. So it took up a lot of space in the article. But the big reason why there were so many references is that a lot of information is skewed or inaccurate or doesn't show good basis of where they're getting their information from. So I had to, in result, use a lot of references to get this information on all these different processes.
So a lot of discrepancies between different authors on the same basic processes. That made it rough on you, I'll admit, but it makes it very rough on our listeners as well on trying to get clear information on it. So hopefully there'll be a lot more research on this in the future that we can clarify and get good direction for society as a whole.
So I hope we did provide some clarity on all these complicated processes and understand a little bit more about the types of recycling that occurs every year.
Mm-hmm. Well, thank you very much for persevering with that article. I know it took you a lot longer than expected. So this has been the TIEEP podcast brought to you by CECO and the Media Lab at the University of Houston. With us were Carla Romero, Hisham Habli, and on the controls, we had Christian Garcia. We'll be back in 2 weeks for more on industrial energy efficiency.